So this is the next question, 3b. So the question is, find the overall transfer function using the block diagram reduction technique for the system shown. Okay, so here you can see that this is one complex block diagram network here. Okay, yeah, this is very tough block diagram. If you see once, you cannot understand what steps, how and all are the steps to do. But if you go step by step, within one by one single steps, I would be providing you the answer for this. This was very tough problem for me as well. I had taken a lot of time to solve this. Okay, so let's try to analyze this problem now. Okay, so first, if you see here, we can see that in this region, this block G3 and this block G4 are meeting at this summing point, or they are getting summed up. Okay, since their direction it's towards the summing point, or they are getting summed up, you can say that these two would be represented as one single block to eliminate this summing point, and we can write this as G3 plus G4 here. Okay, yeah, this is one change. And one more change what I have done here in the next step is, so here there is one takeoff point. I have shifted this takeoff point in front of this block here, as you can see here. Okay, I have shifted this takeoff point in front of this block, and according to the rule of block diagram reduction, whenever we shift a takeoff point in front of the block, whatever the element is there, when we shift in front of the block, that block would be getting divided by the block here. Okay, so that's why this would be written it as G5 by G7 after the shifting takes place. Okay, so those two changes I have made, and I have rewritten the first step here, that is all the things would be remaining as it is. So here in this place the summing point would be gone, and these two would be getting added up, G3 plus G4. Okay, then rest all the things in this step I have written it as it is. Okay, and here this would be replaced by G5 by G7. So now in the next step, what I have done here is I have shifted this summing point behind this block G3 plus G4. Okay, I have done one step here, that is this summing point I have shifted behind the block. Okay, so whenever we shift a summing point behind the block, what we should be doing, it's same as when you shift the takeoff point in front of the block and shift a summing point behind the block, the condition remains the same. It would be getting divided. Okay, so that's why I've shifted this summing point behind the block here. You can see behind this block G3 plus G4, I've shifted it behind, and here what would be doing is this G6 divided by G3 plus G4, since it would be getting divided, so that's why G6 divided by G3 plus G4. And after the shifting takes place, you can see that G3 plus G4 and G7, they would be in series, right? So that's why these both G3 plus G4 and G7 would be getting multiplied. So that's why I've written this as G7 into G3 plus G4, and this as G6 divided by G3 plus G4, and rest all the terms I have kept it as it is, that is G1 G2 block, G5 by G7 and G8. I have not I did not go to touch it. Here I have made one change here. Okay, so hope you understood this step. So please note these two steps down. So here in the next step, what I have done is, so here as you can see that here we would be getting one minor loop here. Okay, for this minor loop we should be applying the condition, that is g of s divided by 1 plus g of s into h of s, in order to remove this summing point, and these two blocks would be replaced by a single block. Okay, so that's why what we have done is here this is the g of s block here. Okay, since this is the feedback path and this is the gain, so that's why this is g of s and this is h of s. Okay, so that's why g of s, I have written it here, g of s divided by 1 plus g of s into h of s, that is this is g of s, G7 into G3 plus G4 is g of s, and G6 divided by G3 plus G4 is h of s. So that we can cancel this G3 plus G4 here. We would be left with G7 into G3 plus G4 divided by 1 plus G7 G6. Okay, so that's why I have done it here. So here you can see that I have replaced it by a single block, and I have removed that summing point. Okay, and I have written it as G7 into G3 plus G4 divided by 1 plus G7 G6. Rest all the terms I have written it as it is. Okay, so in the next step, what I have done is, again this summing point, I have shifted it behind the block in the next step, as you can see. Okay, in order to make the calculation easier, the summing point I've shifted behind the block, so that this path, this here, we would be writing it as G8 divided by this block G1. So G8 by G1 would be written here after shifting takes place, and this is G1, and rest all the things I've written it as it is. So now in the next step, what I've done is this takeoff point, I've shifted it behind the block again. After shifting the summing point behind the block, this takeoff point also I'm shifting it behind the block. When we know that whenever the takeoff points get shifted behind the block, these two would be getting multiplied. Okay, so that's why here I've written it as G1, G2, and here this after shifting takes place, G1 and this term, these two would be in series. So I've written it after in series, we would be multiplying it and writing it as G1, G7 into G3 plus G4 divided by 1 plus G7, G6, and rest all the terms I've written it as it is. Okay. So now in the next step, what I've done is, so since we have here two summing points in a same line, and also we can whenever we have two of the summing points in the same line, we can change the whole complete branch. We can interchange whenever, if you want, you can interchange the branch of these two summing points, that is where this path is meeting, we can change it. Okay. So in order to avoid the calculation of shifting this takeoff point in front or in back of the summing point, what I've done is, this branch here which touches this summing point, I've shifted it to this branch. Okay, this whole branch, you can see that this whole branch I've shifted it towards this summing point here, and this whole branch, okay, where it is touching this summing point, I have shifted it towards this summing point here. Okay, so that's why I've interchanged the position here. Okay, so after interchanging the position, I've rewritten the circuit here once again. Okay, this is the rewritten circuit, so please note it down. Then after that, what I've done is, here we can see that this is one minor path here. This is one single minor loop here. Okay, so that we should be applying G of s divided by 1 plus G of s into H of s, where the value of G of s here is unity and this is H of s. Okay, and after applying the loop here, this summing point would be remaining as it is, because this summing point is holding the two branches here, one this branch and this branch. So that's why after we apply the minor loop condition, okay, that is 1 divided by 1 plus G of s into H of s. G of s is 1 and H of s is G1, G2. The summing point won't be going, because this path would be there here only as it is. Okay, G5 by G7. Okay, so now we can see that these two are in series. Okay, so that's why multiply and write it as G1, G7 into G3 plus G4 divided by 1 plus G1, G2 into 1 plus G6, G7. Rest all the terms, write it as it is. So here we can see that this is one more minor loop here. Okay, so reduce this into a single block. So that's why I've done the separate calculation here by taking this as G of s and taking this as G of s into H of s. Okay, that is, this is G of s and this is H of s. So that's why G5 by G7, if we write it G5 by G7, we can cancel one G7 term here. Okay, this G7 and G7 would be cancelling here, we would be left with only G5. So that's why I've written it as 1 plus G1 G5 into G3 plus G4 into 1 plus G1 G2 1 plus G6 G7. Okay, after that I've simplified this and cancelled these two terms by taking the LCM. This is the term which I've got here. Okay, so now I'm replacing this whole minor loop by this block here, and one final minor loop we are getting here. Okay, this is one final minor loop. For this we should be applying the transfer function formula, that is G of s divided by 1 plus G of s into H of s. Okay, I've written it here. I've written it and I've solved it. Here we have written G8 by G1 here. After all the simplifications, you can pause the video and refer it one by step I've done it. Okay, if you want, you can keep this term as it is. After this step here, you can keep it as it is, or else you can simplify this by multiplying this here, G1 G7 G8 G3 and G1 G7 G8 G4. Okay, and this is the final transfer function which we obtained after the simplification. Okay, that is C of s by R of s. Okay, so please note this down. This is the solution here. So that's all. If you hope you understood this problem very carefully. This is very important. Okay, so please note it down. So this is the next question, 4a, that is, for the block diagram given, obtain the transfer function using Mason's gain formula. Okay, so here this is the block diagram given here in the 4a. Okay, so whenever we want to represent a block diagram in terms of a signal flow graph, I've told you, right, what are the steps, what we should be doing. We should be replacing all the summing points and takeoff points with one node. Okay, and all the gains here we should be representing as the path here along with the direction of the gain. We should be naming it. Okay, and all the paths here, that is feedback paths, we should be representing by these curves. Okay, from one point to another. Since we have here this is one summing point, this is one more summing point, we have one takeoff point, so 4 nodes. This is one more takeoff point, so 5. This is one summing point and this is one takeoff point. So in total we should be drawing 7 nodes. 1, 2, 3, 4, 5, 6, 7. This is input, this is output. Okay. So now what we should be doing is this one takeoff point and one summing point. So from this last point to first point, draw one curve, and here this is the direction. Here the direction is going in this direction, right? So that's why here we don't have any feedback, so that's why it is unity feedback. Since we have here minus sign, so that's why this is minus 1. Similarly, from this takeoff point between G2 and G3, okay, it is touching to the second summing point, okay, with the feedback of H1 minus H1, okay. From here to here the direction is like this, minus H1, okay. And from this point only, this takeoff point, it is touching to this summing point, that is from this point to this summing point, which is represented by one node with the direction in this direction of minus H2. And here from this takeoff point to this summing point, I have drawn it here with the direction like this, that is G4, the gain G4, okay. And this is G1 G2 curve. Yeah, so like this I have drawn the signal flow graph with all the directions and all the gains here. So whenever we don't have any block here, we should be considering it as unity, that is 1, and rest all the terms wherever we have any block between these two summing points, I have represented it by G1. So here I have represented it as G4, H1, H2, minus H1, minus H2 respectively, okay. So in this way we should be constructing the signal flow graph. So now the same thing, all the forward paths, loops and all the non-touching loops taken 2 at a time, 3 at a time, and we should be computing it in the Mason's gain formula, okay. So first thing is forward path. You can see that this one is one forward path from input to output. There is one forward path here from R of S to C of S in a straight line. That is, all the gains will be getting multiplied 1 into G1, 1, G2, G3, 1. So G1, G2, G3. This is the first forward path. And second forward path is like this, and it will be touching this node and it will be moving like this same direction till the output side. That is 1, 1, G1, 1, G4, 1. So that's why G1 into G4. This is the second forward path. So we have only 2 forward paths here in this problem. So write those 2 forward paths, and here we have 5 loop gains, okay. 5 loop gains. I will tell you one by one. First loop L1 is minus G1, G2, G3. So we can see this outer loop here. This is starts from here, okay, and it moves in this direction, and from this point it moves like this, okay. That is G1, G2, G3 and minus 1. So that's why the first loop is outer loop, that is minus G1, G2, G3. So the second loop L2 is minus G1, G2, H1. That is the second small loop here. You can see that is, it starts from here G1, moves in the direction G2, and from this point again it comes to the starting point G1, G2, minus H1. So that's why minus G1, G2, H1, okay. So the third loop is minus G2, G3, H2. That is this loop. From this point it starts 1, G2, G3, 1, and from this point again it moves in this direction and touches this point again. So that's why this is one more loop here, okay. That is G2, G3, minus H2. So that's why minus G2, G3, H2. This is the third loop. And the fourth loop L4 is minus G4, H2, okay. That is again the same thing. From this point it starts, it moves like this in this direction, and it moves up like this same direction, it comes down like this and like this, okay. This loop in this shape, okay. Yeah, I've drawn it in order to make your confusions clear. It is in this shape, okay. This is the loop here, fourth loop, that is 1, G4, 1, H2, minus H2. So minus G4, H2. Finally, similarly, the fifth loop, that is minus G1, G4, that is this. From this point it starts, it moves like this, okay. It comes to this point, it moves upwards, okay. It comes here down, and again same thing, okay. The shape is somehow like this, okay. It starts from here, it moves like this, and it comes again back. So this is the loop here, that is 1, 1, G1, 1, G4, minus 1. So minus G1, G4. Like this we get 5 loop gains here. So there are no non-touching loops here. Since all these loops are touching in this forward path only. So that's why we can say that there are no non-touching loops here. Similarly, there are no loop gains which touch the forward path. So that's why directly we can write it as delta 1 is equal to 1, delta 2 is equal to 1. Then substitute in the Mason's gain formula, that is C of S by R of S is equal to summation k tending to 1 to infinity pk delta k divided by delta, that is P1 delta 1 plus P2 delta 2, since we have only 2 forward paths, divided by delta is represented as 1 minus summation of loop gains, okay, taken 1 at a time, 2 at a time. Since there are no non-touching loops taken 2 at a time, so that's why 1 minus summation of all the loops, that is L1, L2, L3, L4, L5, okay. That is P1 delta 1 substituted, that is G1, G2, G3 into 1 plus G1, G4 into 1 divided by 1 minus L1, okay. Since all the loop gains which we got are all negative, and also we have a negative sign, so minus into minus is plus, so all the L1, L2, L3, L4, L5 which are in negative form, substitute it in positive form and write it, okay. This is L1, L2, L3, L4, L5. I substituted it and written it, okay. So this is the final transfer function C of S into R of S, okay. So hope you understood this problem, so please note it down, okay. When I am explaining, try to note it down, okay, so that you can understand, okay. So this was that problem, hope you understood. So this is the next question, 4b, very simple question for 5 marks. This has been asked in the model paper for 5 marks, okay. Very simple question, that is, we need to determine the transfer function, that is the relationship between output and input for the given system shown, okay. Yeah, so here this is the given system here. So it is given in T domain. In order to represent in S domain, resistances would be remaining as it is. C would be replaced by 1 by Cs, okay, and rest all the terms. This is Vi of t and this is V out of t. So here apply one loop here, that is name that loop as I of S. It is common for these two, okay. So that's why apply KVL on this loop, that is Vi of S, since it is represented in S domain. So Vi of S minus R1 into I of S minus R2 into I of S minus 1 by Cs into I of S is equal to 0. Then Vi of S is equal to, take this all the minus sign to the where it is 0 after the equal to sign, so that's why the 0 would be vanished. So Vi of S is equal to R1 into I of S plus R2 into I of S plus 1 by Cs into I of S, okay. Yeah, so the 0 is not there. So therefore in this equation we can see that I of S is common. Take that I of S common outside and write the remaining terms, that is Vi of S is equal to R1 plus R2 plus 1 by Cs into I of S, okay. So name this equation whatever you got as equation 1. Also now apply KVL for this loop here, okay, from this direction, outward signs you should be checking, okay, in this direction, that is outward, this is plus, so plus V naught S minus, if it comes like this, so this is the negative sign, so minus, it comes like this, so this is the negative sign, so minus R2 into I of S, again minus 1 by Cs into I of S equal to 0. So V naught of S is equal to, take this minus to other side, so that's why it would be plus R2, and I of S is common, so that's why plus R2 plus 1 by Cs into I of S. So name this as equation 2. So now from equation 2 we can compute the value of I of S, that is V naught of S is equal to, so take this LCM here, so that is multiply this, so R2 Cs plus 1 divided by Cs into I of S. So V naught of S into Cs is equal to R2 Cs plus 1 R2 Cs plus 1 into I of S. So from this we would be getting the I of S value as V naught of S into Cs divided by R2 Cs plus 1, okay. So this is the value of I of S which we computed from equation 2, okay. So now whatever the value of I of S we got here, we should put this back in equation 1 whatever we got, okay. So put the value of I of S in equation 1, that is Vi of S is equal to R1 plus R2 plus 1 by Cs into, in place of I of S, that is we should be putting V naught of S into Cs divided by 1 plus R2 into Cs. So our Vi of S would be, take the LCM here, okay, that is CSR1 plus CSR2 plus 1 divided by Cs into the same thing, so that we can cancel this Cs here. So after the cancelling out, write the remaining terms, that is Vi of S is equal to CSR1 plus CSR2 plus 1 into V naught of S divided by 1 plus CSR2, okay. So that's why from this we can compute the value of V naught of S divided by Vi of S, that is bring this Vi of S this side and bring this CSR1 to the denominator side. So that's why V naught of S by divided by Vi of S is equal to, replace the terms, that is 1 plus R2 Cs divided by 1 plus R1 plus R2 Cs. So here in this case Cs is common, so that's why I have taken it outside, I have written it as 1 plus R1 plus R2 Cs, okay. So this is the simple transfer function, that is relationship between output and input for the simple network shown. Hope you understood this problem. This problem is very easy, so please go through this problem, and whatever the problems I have provided you all, so please try to write it handwritten, okay. Whatever problems I display, write it and practice this, so that you would be beneficial for the exam, it would be beneficial for you for the exam, okay. So that's all, please note it down. Thank you.